Okay, I'm going to walk you through solving equations, and we'll kind of just go from easy to medium to hard. All of this is kind of a review of what you learned in Algebra 1 and need to use in really every unit in geometry. And geometry sets up the problem, it tells you relationships, but in the end, you're still going to need some algebra skills to end up solving for a variable. So let's look at some one-step equations. So on this, let's look at these left four. This says x plus 3 equals to 10. And what we want to do here is, first of all, mental math tells us that x represents some number, and we're like, okay, 1 plus 3 equals to 10. Well, of course, 7 plus 3 is equal to 10. So we know the solution to that first one is 7. But what we want to do is algebraically being able to solve it. And so if we use some algebra, what we can do here is we want to use the inverse operation. And I kind of started you with the first kind of 4. This is a plus 3, a minus 7, or subtraction. 4x is 4 times x, so that's multiplication. And then x divided by 5 is division. And so how you undo those operations is by using their inverse, okay? So if we want to get rid of a positive 3 and x plus 3, and then we want to subtract for both sides. Now again, I'm not going to always do this, but what you're doing here is that you are subtracting 3 from both sides of the equation. If you subtract 3 from both sides of the equation, x plus 3 minus 3, well, do you see how the positive 3 and the negative 3 undo each other? They cancel. Cancel is not necessarily the most technical math term, but it does work in most discussions. And then over here, you have 10 minus 3, and of course you get 7, and 7 is the solution that we already knew. And so what we have is that we solve the equation using inverse operations. Let's look at this one now. X minus 7 equals to 5. Well, let's get rid of the subtraction by 7, and let's add 7 to both sides. So I'm going to add 7 to both sides. X minus 7 plus 7, right? The subtracting 7 and adding 7 doesn't do anything, so we're left with just x on the left side, and then 5 plus 7, of course, is 12. Right? And of course, 12 is the solution, right? 12 minus 7 equals 5. And again, the whole idea is that we're using the property of what an equation is, right? An equation is a balance of two, the left side and the right side. And when you have a balance, you can do anything you want to the left side and to the right side. And as long as you do the same thing to both sides of the equation is still balanced, meaning it's still a true statement. And so as long as I add 7 here and add 7 here, I'm fine. Here, I'm going to divide both sides by 4. Let's divide this by 4 and divide this by 4. Multiplying by 4 and then dividing by 4, right, those undo each other, and you're left with x equals 36 divided by 4, of course, is 9. Here I want to undo division, so I'm going to multiply both sides by 5. 5 times x divided by 5, well, 5 divided by 5 is just 1, and 1 times x, of course, is just x, and so then I get x equals 35. Right, so I'm using the inverse operation to undo parts. It's really using the reverse order of operations to solve for x. These are kind of one-steppers, right? You could have done those in your head. I hope you can do this in your head too, right? Something plus 3 equals 15. Well, something plus 3, this something must be 12, because 12 plus 3 is 15. Well, what times 2 is 12? Well, it must be 6, right? 2 times 6 is 12. 12 plus 3 is 15. So mentally, we know the answer is 6. But algebraically, we're going to subtract 3 from both sides. When you subtract 3 from both sides, you get that, right? 12 minus 15 minus 3 is 12, and the subtracting 3 gets rid of the addition. And then I'm going to divide both sides by 2. Again, I am just doing the inverse operation, right? Same thing down here. I'm going to subtract 5. Again, I'm going to work on the outside, the furthest thing from the x on this side of the equation, right? This negative 4 is multiplying by this x, but this 5 is chilling out here all by itself. So I'm going to subtract 5 from both sides. Subtracting 5 from 37 gives you 32. And now I'm going to divide by negative 4. Again, this is negative 4 times x. So to get rid of multiplication, I need to use division. So I'm going to divide both sides by negative 4. 32 divided by negative 4 is negative 8. Again, a positive divided by a negative is in fact a negative. Okay, here I'm going to add 11 to both sides. Negative 7 plus 11 is going to be positive 4. And then to get rid of this division by 3, I'm going to multiply both sides by 3 and get 12. Okay, so those all kind of just took 2 steps. Okay, the next one, 4x minus 3. Okay, ooh, now I have x's on both sides of the equation. So what I'm going to look at combining like terms. I'm going to get the x's to the right side of the equation and the numbers to the left side, or the constants to the left side. I only picked the right side for the x's because there are 9 here and 4 here. So what I'm going to do is I'm going to subtract 4x to both sides. Okay, I'm going to show you this one with some work. I'm going to subtract 4x to both sides, and then the next line would be negative 3. 9x minus 4x is 5x, and I didn't really do anything to the numbers. Now I'm going to add 18, so I'm going to move the 18 over here. Negative 3 plus 18 is positive 15. And now I'm going to divide by 5, because this is 5x, this is multiplying, and so I'm going to divide and get x equals 3. And again, you can check your answer if you wanted to. If you check your answer, 4 times 3 is 12. 12 minus 3 is 9. So the left side of the equation is 9. And then 9 times 3 is 27. 27 minus 18 is 9. And so when you plug in your solution, you get a true statement, meaning your equation is balanced. That's what it means to be a solution. You've solved the equation. Okay, here I'm not going to write all of this down, but I'm going to do the same steps. I'm going to add this x, right? This is minus 1x, so I'm going to add the x to the other side, which will put 6 x's on this side. And I'm going to add the 35 over here, which will make that 42, 7 plus 35, and I'm going to divide by 6 and get x equals 7. And again, you can plug that in. Negative 7 plus 7 is 0. 5 times 7 is 35. 35 minus 35 is 0. 0 does equal 0. Bingo, it works. Okay, down here, I have to distribute first. But once I distribute, I'm going to get something that looks like this. And then once I work with this, it looks something like this. Everything eventually becomes a one step, right? So let's distribute. 3 times the quantity x minus 4 is just 3x minus 12, right? I distributed the 3 to both. That plus 2 is just going to chill. 4, and I'm going to distribute this negative 5. Negative 5 times 3 is negative 15. Negative 5 times negative x is going to be a positive 5x. Now I'm going to simplify. Combining like terms on this side, I'm going to have a negative 12 with a positive 2 to give me a minus 10. And then over here, 4 minus 15 is negative 11. And now I'm going to combine like terms on different sides of the equation. I'm going to subtract 3x. Right, 5x, I'm going to move the 3x to this side by subtraction, and I'm going to be only left with 2. And then I'm going to add 11 to this side. Negative 10 plus 11 is 1. And now I'm going to divide by 2, and it turns out that I get a fraction, 1/2, right? Or 0.5 as a decimal. No big deal to get fractions. You're going to get fractions every now and then. Okay? So 1 step, 2 step, multi-step with the variables on both sides, and then this one even added another step with kind of distributing. Okay, 3 more problems and we're done. Okay, this one just has fractions to begin with. What you're going to do is that the easiest thing is you're going to multiply by the lowest common denominator. Remember the LCD, the denominator here is 2 and a 5. So what I'm going to do is I'm going to multiply both sides of the equation by 10. 10 is the lowest common multiple of 2 and 5. So I'm going to multiply the left side by 10 and the right side by 10. But when I multiply the left side by 10, I'm really multiplying that guy by 10, that guy by 10, and then the right side, that guy by 10, and that guy by 10, right? These are 2 different terms on both sides. Order of operations says that I don't have to do 10 times x and then divide by 2. I can actually do 10 divided by 2. 10 divided by 2 is 5. 5 times x is going to be 5x. 10 times 3 is 30. 10 times 4 is 40. 10 divided by 5 is 2. And then 2 times negative x is negative 2x. And I've gotten rid of the fractions. If you multiply by the lowest common denominator, the beauty of that is that the fractions will go away. And now you're just left with like a normal thing. I'm going to add 2x to this side and get 7x. And I'm going to subtract 30 to this side and get 10. And then I'm left with dividing by 7, and I get 10/7 as my answer. Okay? Over here, this is kind of where we could use square roots. See how there's no like x's here? It's just x squares and numbers. So what I can do is I can subtract 3 to the other side, and then I can take the square root of both sides. Take the square root here and the square root here, and you have to remind yourself that you have to introduce the plus or minus. Remember, the square root of x squared is just x. And then I have to introduce plus or minus the square root of 25. And I did pick a perfect square. So the square root of 25 is in fact 5. Remember, the solutions are both 5 and negative 5 because both of those, when you square them, you get 25. 25 plus 3 is 28. Okay, so this is using square roots. And then the last one is kind of our classic quadratic kind of double bubble, right? When you see one of these trinomials, you're really going to think, okay, I think maybe double bubble is going to work. And what I know about my foiling or reverse foiling is that maybe I can put an x here and an x here, because when I multiply, I'm going to get x times x to give me x squared. And now I'm thinking of factors of 10 that have a difference of 3 because this is a minus sign. We're like, oh, cool. How about 5? And then 2, and then you think, okay, which one's positive and which one's negative? Well, this is going to be a 5x and a 2x. But you see how that middle is a negative 3? So I'm going to want the 5 to be negative and the 2 to be positive, because I'm going to want a negative 5x and a positive 2x to give me negative 3x. And I have to keep going. I have one more step. I have to solve. So if this times this equals 0, the solution is, well, what makes this 0? Well, positive 5 makes that 0, right? 5 minus 5 is 0. And then here, if x is negative 2, it's going to make that 0. Both of these x values make this or this one 0, which makes the equation true. And again, you can plug them into the original green if you want. So on this side, I got rid of fractions, I use square roots, and I use quadratics. And they're kind of just building on these first principles of 1-step, 2-step, 3-step, and then, multi-step solving equations. The beauty of an equation is that you can always check your answer, and you're using algebra. You're manipulating both sides of the equation with adding things, subtracting things, multiplying, dividing, and in the back you're even square rooting and squaring things to solve equations. Hopefully this reminds you of a lot of the skills you have in Algebra 1 and you're ready to solve problems in geometry.